Well done, everyone. Today we are creating ERC20 token, and each of us will customize our ERC20 token that we created. So, before you start, try and get the following items down. Number one, the name you want to use for your ERC token. In my own case, I want to name it Bravolac token. So, number two, decide the symbol you will use on your ERC20 token. In my own case, I want to use capital letters BRK for the symbols. Then number three, you have to decide the your initial total supply of the token. So in my own case, I want to I want the initial total supply to be 1 million. So after that, the next thing is for me to go and create the GitHub repository. The setup is the same with what we have in our last practice, where we created simple storage smart contract. So I'll open my browser. I'll open my browser and go straight to. I will go straight to GitHub. So this is my previous GitHub account. So when I get to GitHub, I will create new repository. So with this plus symbol, new repository. I'll click on new repository. So I'll create new repository. So in this repository, the username is Bravolac Media. So you can see slash, then I will bring the name I want to name my repository. So to make it simpler and very easy to identify, I'll use Bravolac token. Bravolac dash token. You can see it's in small letter. So description. Add description for your ERC20 token. So this Bravolac token, Bravolac token is an ERC20 token. It's an ERC20 token created for sample projects. For sample projects for tutoring, for tutoring in TechCrush Web3 cohort 5 Web3 cohort 5 bootcamp. So your own narration may be different. You can say your sample projects for Web3 bootcamp, cohort 5 bootcamp. So it may not be in your own description. You may not name it. You may not include for tutoring. Your own will be for practice. So next, under configuration, set your visibility to public. It's already in public, so you don't need to change it. Scroll down. Then the next thing is readme. Come here and add readme. So you just turn this toggle or button, turn it on. So readme will be added like this. Then the next thing come to create GitHub. You can see add.gitignore So let's add gtignore. Add gtignore so that I think we can add gtignore later. Let's leave it. Let's leave gtignore and add it later. It's like gtignore 2 will be created when we use Foundry. So let's don't add gtignore here. Create. Click on create. Create the repository. So this is the first step. I've created the repository. So this first step. So second step, we have to clone the repository. So remember how we close the repository? You will come to code here. When you have code here, come and copy the URL. Copy the URL here. Then proceed to your terminal. Proceed to your terminal. So if you remember, we have been working inside Web3 practice folder. So I will now go into the folder. The folder is inside my documents. So you should remember where your own is located and go to that place precisely where you created your first simple storage smart contract. So I will firstly go into my own documents, enter. Then inside documents, I will go into Web3 Web3 practice folder. Web3 practice folder. So inside Web3 practice folder, so I will now do this is where I have my simple storage smart contract. If I do ls to list the items, you can see this is where I have my simple storage contract. So I'm in the right directory. So in this place, I will now I will clone the repository that I've copied. Git clone, then I'll paste the repository URL. So you can see it's cloning Bravolac token repository. It has finished cloning it into this directory. So next thing is for me to go into the Bravolac token folder. I mean, yes, folder Bravolac token. So I have it now on my local machine. It has opened. Then I will do code space dot to open it on Visual Studio Code. So it's opening on Visual Studio Code. So that's the second stage. Now I have my Bravolac token folder open. So the next thing, I will open a new terminal. This is the third stage. Close this welcome page from Visual Studio Code. Then I will go to the terminal. I will open new terminal. So this is the third stage. In the third stage, after opening the new terminal, I will come into the terminal here and initiate a Foundry project inside the Bravolac token. So remember the command forge init, then the name of the project Bravolac token. Forge init Bravolac token. So it's initializing Bravolac token. So the project has been initialized. Then the next thing, cd Bravolac token. So you will now see that I have the token inside another repository. Inside another repository now. If I come here, the token is now living inside here, and this one is having its own readme.md again. Wow, we have repository inside repository. Okay, let's move on. We'll find a way of correcting this. It's always good to have everything inside one repository. But now we're having repository inside repository. Okay. So the next thing, we are going to install Open Zeppelin in our Bravo token. Install Open Zeppelin. Forge install space Open Zeppelin capital O, Open capital Z Zeppelin, Open Zeppelin slash forge install Open Zeppelin slash Open Zeppelin, Open Zeppelin slash Open Zeppelin dash contracts, enter. So we're installing Open Zeppelin. So Open Zeppelin is coming up 1%, 2%. So we wait till the Open Zeppelin installation is complete. So we wait for Open Zeppelin installation to complete. This tool readme, find a way of correcting it. Find a way of correcting this. It's not good to be having to be having repository inside repository. So 14%. We'll wait for this to complete. 22% now. 22% done. We are still waiting. We are still waiting for this to complete. We are waiting for it to complete. That's 1% done. That's 1% done. It's now 50%. 50% done. It's now 50% done. %77%. So when this process is completed, first thing we're going to do is to write the ERC20 contract. That will be step 5. I'm going to write the ERC20 contract. You can see in this place, we have our basic folders already supplied. We have our scripts folder where we are going to write deployment scripts, SRC folder where we are going to write our ERC20 smart contract, and test where we are going to write the test for the ERC20 contracts. Yes, it's completed. Now, the first, go into SRC. You can see our counter.so contract comes with it. So click on the SRC and create your file for ERC20 token. So the file. Now this file, I will name it Bravolac. Remember, you start with capital letter. Follow the formats they use for creating this counter contract. So Bravolac token capital T dot so this will be the smart contracts folder. So remember, we always start with our license, capital SPDX license, small letter SPDX, capital L, then the rest is small, license, SPDX license, identifier, then colon, NIT. So these are license. The next thing is to define our solidity version. Pragma solidity, and we've consistently been using version, a stable version 0.8.20. So that's our stable version. Next is our importation statement. Import. So this time we are importing from OpenZeppelin. Import OpenZeppelin contract. Import OpenZeppelin contracts from contracts folder. Slash. Inside the contract folder, look for the token, and under the token, look for the type of the token. Remember, we have different tokens. ERC20 token, ERC20, then slash ERC20.so. So this is the actual file, ERC20.so. Then our semicolon. So this word tells the solidity that this importation statement has ended here. So if you don't put it, you have error. So import. The second thing to import from, we are still importing from OpenZeppelin. So OpenZeppelin contracts, we are still importing from contracts folder, slash, from contract as well, contracts, we are importing from contracts, then slash token, importing. So this time we want to grab ERC20 extensions. So slash ERC20 slash extensions. So we are going to use extensions. So we want to import basic functions that we are using. So one of the functions we are going to use is ERC20 burnable function. ERC20 burnable function. So meaning that on this our smart contract, we want to enable burnable function so that you can burn the token. The token will be burnable. Next, import from OpenZeppelin, import OpenZeppelin contracts from the contracts folder, from contract folder, then from token, then from ERC20, the next one is still an extension, from ERC token, ERC20, then we are grabbing extension folder, then inside the extension, we want to import another extension which is possible function slash ERC20 slash ERC20, then this time possible ERC20 possible.so. So this one is done. So that's our possible function. The next one is what? Our access, the one that will enable us to define the access control for who can meet the token and who has certain ownership function. So import from OpenZeppelin contracts, OpenZeppelin contracts slash from contract folder slash from token folder slash ERC20, then slash extensions, from extensions folder, then we are grabbing access. Oh, I've made a mistake. So after contracts, we go to access folder straight. It's not on that token. After contracts, after contracts, we go straight to access folder. Access folder. Then from access folder, we grab enable.so. So this is where ownership access is located. So we are done with our importations. So make sure there is no error in what you import. If there is error, at the end of the day, you'll be having bugs. It will be throwing error when you are running your application. Now let's write the smart contract itself. So we define the contract. So this is the smart contract for creating the token. Contract Bravolac Media. Sorry, Bravolac token rather. Contract Bravolac token is what? Is type of ERC20 token. ERC20 is ERC20, comma, and remember the functions we want to use on it is going to be what? Burnable. So ERC20 burnable is burnable. Then it's going to be possible. So ERC20 possible is possible. Then it has ownership. Then we say ownable. Then the object notation to make it a function. So everything we are going to do now should be inside this object notation. So we will now define the object of the token. The properties of the object, which is the token that we are creating. So we start with a constructor. Constructor. Then, so this constructor will define the interface of our token. So our token, the token is going to have a name. So the name is string. Then we'll commit the name to memory so that it will be in the memory of the blockchain. So name underscore. So this gives the token a name, string memory name underscore. Then we commit the name to his memory so that he will always remember it. Then the symbol, string memory symbol. So we are passing symbol. So the token will have a symbol. We are telling the system that the token will have a symbol. And you should always remember the symbol as a symbol for our token. Then it's going to have the number of supply, the initial amount that we supply when we minted it. And this one is going to be a data type of integer. And since it's the initial amount we supply, it will not be negative. So we are using unsigned integer. Unsigned integer of 256 character. Define our initial, define the data type for our initial supply. Initial supply. So this is the interface of our token, which we pass inside the constructor. So make sure you are not going outside this object notation, but I'm now going outside the constructor. I'm through with the interface here. So I will now come to the ending of the second bracket here. Space. I put space here. Then ERC20, ERC20. Then I define the ERC20. I pass the name that I've declared its interface here using the constructor. So I will now pass the name into the ERC20 as an input. Then I pass, still go back here, comma, then I pass the symbol, I pass the symbol of the token to the token. Then I come outside, I declare the enable function. So enable, I pass input to it with this message dot sender. So meaning that here the enable function will always check who is trying to access the enable function. So if the sender is not somebody that is assigned as the normal sender, it will be rejecting it. But if it's the real sender, it will be accepting it. So enable dot sender. Now I'll put space, then object notation to make this a function again. Then I press enter. So inside the object notation, which is still within the smart contracts as a whole, I will now pass the mint. Function such that only the owner will now be able to mint. So you can see we don't use the mint function in the initial something. So we only use the mint function in a special function that is wrapped within the ERC20 token, which is passed to only the owner. So this ensures that only the owner will be able to mint the token. So underscore mint, it's like a constructor on its own. So we pass the input to it, message dot sender. So meaning only this sender will be able to mint here. Message dot sender, comma. Then inside this, another input, in our interface for the ERC20 token here, we initiate the total supply, but we don't pass it to the token here. So we'll now pass that one to the owner such that the owner will be able to mint the initial supply. So that is passed to only the owner. Then star will now define the what do you call it? We'll define the decimal places we can have on the token. So we'll make it 10. Then star. So this should be seen as the decimal places on the token. Then It depends, and sometimes it depends on the token. Like if the token is on Solana, Solana token normally have 9 places of decimal. So this we have passed the initial supply something to the owner here. Then the next, I think the next we have to do now is to declare the functions for possible and for vulnerable activity. I think that's what is next. So so we now come to this place. We come outside of the ownable function. You know we are still in ownable function here. So we have passed ability to mint to the owner, and the owner should be able to mint the total supply. Then we define the decimal place for the supply. Then we come here and press enter, and still make sure we are within the smart contract, so we don't come outside of this place. We are still within the smart contract. So how come you have comma here? You don't have comma here. So it's this place. Okay. So we come here. So what we do here now is, what remains now is for us to define our functions: the possible, the vulnerable, and the mintable function. Ability to mint it. That's the next thing we. That's the next thing we have to do. So function, function pause, function pause, function pause, space, external. So we are defining the function for pause. Firstly, we set the visibility to external. So owner, only owner should be able to pause the token, then put object notation to complete that. Then we pass the function underscore pause. Pass the function of pausing to the owner. Then come outside here, still within the smart contract. So when we pause, we should be able to unpause when we've corrected anything we want to correct and want to unpause. So function unpause. So don't put pause and forget to put function to unpause. That would be a bug, and it can cause permanent lock on your token. That's a vulnerability. So external, we still set visibility to external. Then we pass the function to only the owner can do that. Then the objects on pause. Press enter here, then pass the function. Pass the on pause ability. Sorry, on pause. On pause. So this make it possible to pause and unpause the token. Then space. Take note of where I'm putting when I'm pressing my enter. After the function for unpause, declare function for pause, then the function for unpause. Then outside it, still within the smart contract. You can see where my cursor is blinking. So I'll now define the minting function. Ability to mint, function space mint. So when we are minting, to which address are we minting? To which address are we creating a new token and send it to? So address to that the new token will go to. Then the token will have number that will not be negative. So the data type will be assign it to guy 256 character, and that's double 256. Then it will have amounts. How many are we sending? We will define the amount we are sending. We will define the amounts we are sending. So then we set this to external, we set it to external, and we pass the function towards only the owner. Pass the function to only the owner. Then that's a function. We complete it with the object notation there and pass ability to meet underscore meet. Then when we meet, where are we meeting to? So where are we meeting and what's the amount we are meeting? We pass the amount we are meeting as an input. So the meeting function is completed now. So the owner will be able to meet with this function. Then we come outside the object something for where we define meeting function. We are still inside the smart contract. So after meeting, we should be able to update the information we have on the token. So set function functions space underscore updates. So whenever we meet, we should be able to update the balance we have in the initial supply and the balance we'll be having for a particular person that the token has been minted for. So function underscore update. So let's define the properties of this function. Address. So we should be able to update address from. On the update function, we'll get address from where the token is coming. We'll get address to where the token is going. Address to where the token is going. Then the amount, which is unsigned integer of 256 character, and the value, the amount that actually goes to that address. Then we come to the next line. Still on the line for the function on the line for the update function code. Internal, we define the feasibility to be internal. Then the thing should be able to override so that it can update. It should be able to override the initial state of the token. So ERC20, it will override the ERC20 status and bring ERC20 possible into effect here, so that if you want to pause, this what will actually allow us to pause by what? By updating the states of the contract from unpause to pause. Then it can also update it back to unpause. Then we have object notation. We pass object notation and define the inputs that will be affected when we want to update. So super dot underscore update to be able to update. Then we are updating from address from where the token is coming to where the token is going, and the value that will be the new value that will be passed to the present state. So we are through with the we're now through with our ERC20 token, Bravolag token. So Command S, you can save. You can save this. So the next thing now for us is to go and write our test case. So for us to be sure we are through with this, we can try and do forge let's do forge build and see if the smart contract will really build. So we go into the terminal, say forge build. So it's compiling. Invalid version pragma expected. The start of the version number, but instead find character I. Version number is invalid, or the pragma is not terminated with a semicolon. That's line what? 0 points. Okay, so you can see now we did not terminate the code here. That's why it's throwing error. So always ensure you do proper thing. Command S. Let's come back and run the forge build again. It's saying that identifier not found or not unique. Bravolac token, internal override, internal override. Oh, there's a spelling mistake there. That's code line 30. Code line 30, override, override, double R, command S. So, forge build. Our import statements. Okay, it's asking us to use name. It has run. Can you see? Compiler runs successful. So this one is just a warning telling us to use name import. But our compilation, you can see it finished at this time, 1.82 seconds, and it runs successfully. So for us to know that, so if we like, we can correct our import just like what is just like the warning here. This is not an error, it's just a warning. So that we should import specific things we need. That's what it's saying. So we can go ahead and import specific things. And if you like, we can ignore it and continue with our job. So what we're after is to actually compile, to build, and we have been able to build successfully. For you to know we build successfully, you can see this out folder has been generated. So if you come to this out folder now, you will see our Bravolac token. You can see Bravolac token.so. So meaning this is the Bravolac token JSON. So telling us that we have a successful build. We have compiled it successfully. So for the purpose of this, we are going to ignore the warning. But if you like, you can make correction. But we are going to ignore the warning because of time and move on to the next. Let's go and test. So our contract has been successfully written. Now we have to test it first before we attempt to deploy. That's a good practice. So you now discover that the testing will even take you more time than the smart contract building. But as a good developer, it's always good to test. So don't say because of the time it takes that you will not test. So inside the test folder, come to this place, create the folder for test, I'm still typing test. Just name your test. Follow the naming you have here. You have for counter.t.so here. So our own now will be Bravolac token.t.so. So in the test, I'm creating the test folder, Bravolac Bravolac token. capital T, bravula token dot T dot sol. So telling us that it's a test folder. I'm making sure I did it. I do this inside the test folder. So the first thing first, uh, the license SPDX license SPDX license identifier SPDX license identifier colon, that's MIT. The next, let's remove this. So the next should be our pragma solidity. Pragma solidity version, stable version 0.8.20. So let's not forget our semicolon this time around. Now we import from 4JS standard, import for test, import your string, import Forge standard for testing, Forge standard for test, and grab test dot so, grab test dot so. Next, import Forge standard, sorry, not Forge standard this time, the contract we want to test slash src slash, we now import our bravula token dot so, then our line break, which is semicolon. So we are finished, we are through with importation. Now this is the longest coding we are going to have in this code, this contract. So let's define the contract and set up the testing environment. So contract bravula token test. Don't forget, bravula token test is what? Is test. Is test. Then the object notation for us to complete defining our function. So inside it, we set bravula token as token. Then we pass the address owner. Who is the owner of the address? That will be the address of the token. The address of the owner is the address of the token. So here we use this. So the address we pass for the owner is what the token will have as its address. Then let's say in our tests we want to use Eliza's address. So let's say address of Eliza is the address we want to mint to. We want to, for testing the mint, minting option. So let's say Eliza address is 0 times 0x1. Now this is the string that our address normally starts with. So let's say that's the address for Eliza. And let's say we want to, maybe we want to mint to address of, let's say we want to mint to address of Faith as well. So address of Faith is our second address that we can mint to. So pass this. Let's say Faith address is times 2, 0, 2. That's a string for address that we copy from their meta. Remember, this is just a excuse me. Remember, this is just a mock. We are mocking the address. This is not their real address, but we are mocking it now to see what will be the behavior of the uh, contract we are testing. So next thing, the integer, unsigned integer 256 character that will define the initial amount. So because before we constant before we can send meet and send, the test must know the initial supply of the token. Excuse me. Initial. So we are passing unsigned integer of which is constant. No, initial supply must be constant. It's not something that will be changing. Initial supply. Let me use cap lock. Okay. Initial supply. So we pass initial supply. So we are mocking initial supply here. So I said, so here you use underscore to introduce your initial supply. So you don't just type 1000, it will see it as a, sorry, it will see it as a number rather than integer. So that's why I put all this underscore 1000. Sorry, this 1 million. Then break the code. So next thing now is to set up the test using our setup function. So function setup, function setup. Remember it's capital P, capital U. Function setup. We set the visibility to public. Set visibility to public. Then the object for the function setup. So here we will now pass the token properties. So we instantiate for every new instance of the token. Token equals to new new every token is new Bravolac token. It's new Bravolac token. Every token is new Bravolac token. Then we now define the we'll pass the metadata that will be on the on every new Bravolac token. So on that every new Bravolac token, we want the name. The name is string named Bravolac token. Then excuse me, it has symbol which I said initially I want to pass that as BRK. Sorry, let me use BVK. Let's use BVK, but I should not forget to make sure I'm not changing it. Let me use BVK. Then I will now pass the initial supply. So for every token, this is the these are the metadata that it will carry. So now I've set up the function. So now check the function object notation starts here and ends here. So where the first setup function object notation end, that's where I will move out. But I'm still within the test. I'm still within the test folder. So I will now test each of the functions that we enabled the other time. It's not what I will test. So part of what we are testing now, we'll test deployment, we'll test transfer, how it will work. We'll test possible function, we'll test unpaused function, we'll test a burnable function and mutable function. So you can see we have like 6 things to test. So now let's do a kind of what do we call it? Let's do a kind of what's the name? Documentation. Let's do slide documentation where we comment on what we are doing. So let's say the first one, we start with deployment. So we are saying that in this code file, in the next code block, we are implementing deployment. So we'll comment this out. So let's comment this out. Function, oh, sorry. Function test initial supply minted to owner. We are testing initial supply minted to owner. After deployment, we send it to public. We set the visibility to public. Then our function notation, our object notation to complete the function. Unsigned integer of 256 character. Then we pass the expected supply, the amount we expect to be supplied to the owner after deployment. So that amount should be initial supply. Sorry. That initial supply should have decimal places of 10, which is the decimal place we have specified. Then that should be that should be token, that should be our token dot decimals. That's the number of decimal places we can have on the token. We are testing, so we'll pass those expected features that we expect on it, because the test will not understand that we are the one to mock it. So we are mocking now. So assert equal. So we are going to make sure that what we get is controlled. Assert equal token dot total supply. So make sure that the total supply we get is actually the actual amount that we intend to mint out in our testing. So then we pass expected supply air as our input in assert equal expected supply, then terminate the code air. Then the next is assert equal again. So what are we asserting in this case? Token dot balance. After minting, the token should show the balance for what? For the owner. Balance of the owner. It should show us the balance, the token balance the owner is having in his account now. So here it will pass the expected supply to, because the total supply should be what we are paying here for the owner. So we'll break this. So we are through with the deployment testing, the code for deployment testing. So we are still within the smart contract, but we are now outside the deployment function. So let's check the case for let's write the test for transfers. So we want to test for transfers, ability to transfer the token from one wallet to another. So it's the duty of the developer to effect that. So we'll test for it as well. Function test transfer, function test transfer between, we want to test transfer of the token between wallets. and ensure wallet can be able to transfer the tokens. Set its visibility to public. Sorry. Set its visibility to token, then the object notation, then unsigned integer of 256 character. We define the amount that we are trying to send. So let's say in this instance, we mark the amount we want to send. Let's say we want to send 1,000 units of the token. What is the decimal place on it? 10. Then seen as the token decimal. Token dot decimals. Token decimals. Then break the code here, end the code mark here, then enter. So what do we want to do? We want to transfer. So token dot transfer. Token dot transfer. I've made mistake. So always take note. Transfer. So what am I transferring it to? I said I want to transfer to Eliza. I'm just testing. I'm mocking it. Amount. Remember the address I used there is not correct. It's not real life address. It's just mocking. So, comma. So you pass the Eliza as the input, the person that the wallet to be transferred to, and the amount that will be transferred to it. And that amount has been stated there. I've declared the variable of the amount here to be 1,000 units. So if this thing is working, 1,000 will be sent to, it will say that 1,000 token, 1,000 blah token has been sent to Eliza. Then I move down, assert equal token. After transferring, there should be the balance should reflect on the Eliza wallet. So balance, so it should be able to show us balance of Eliza. It should be able to show us the balance Eliza is having now. Balance of Eliza. Then the balance should be the amount that has been sent to Eliza, which in this case we expect it to be 1,000 Bravolag token. Then assert equal. So what are we asserting now? Token dot balance of the owner. Who is now the owner of the token? Eliza. So token dot balance of the owner. Okay, sorry. What we are now asserting here is that the token, after being sent, the owner token should be able to be updated. That is, the person that minted the token in the first instance, his balance should be updated such that 1,000 that has been sent to Eliza must be deducted from his own token. So instead of 1 million token now, we will now be having 1 million minus that's 1,000. So we now have token dot balance of owner, comma, token balance of the owner should now be token dot, what's the total supply? Total supply of the token. Total supply of the token minus the amount, which is the amount sent to Eliza in this test, so that the token info will now be able to be updated. So with this, we are through with the transfer testing. We are through with testing for the transfer. Now we can go to testing for minting. So we'll still make sure we are within the within the test file. So let's test for minting. Let's test for minting the token. Minting. I want to test for minting the token. Test for minting. So to test for minting, function, let's go one line down. Function test owner. Function test owner can meet. Test owner can meet. Test owner can meet. We set the feasibility to public, then the function notation, the object notation for completing the function, then the data type unsigned integer of 256 character, the amount that the owner will meet. Let's say, for example, the owner wants to meet 500 to Eliza. So 500, we want to meet 500 to Eliza. We define the decimal place on it, which is 10. Then we token dot decimals so that the Solidity will understand this as decimal on the token. Then terminate this this variable declaration. Then we move on. Token dot mint, and who are we minting to? We want to mint to Eliza. Maybe we should mint to Faith this time around. Okay, let's say token dot mint to Faith. In as much we also have Faith, don't let everything go to Eliza. So token dot mint to Faith, the amount we are minting to Faith, colon, semicolon, then assert equal token balance now. Token dot balance of whom? It will now be balance of Faith, no more Eliza. There is still Eliza, but this time around we are meeting to Faith. Token dot balance of Faith, comma, the amount we are meeting to Faith, then semicolon. I think we're through with testing for minting. We're through with testing for minting. Then to function test, let's test that non-owner cannot mint. Non-owner. So the first one is testing for owner can mint. So remember, you should be able to test for negative conditional and other edge cases too. So function test non-owner can mint. We want to test that someone who is not the owner cannot mint. Test non-owner cannot mint. So to test that non-owner cannot mint, set it to public, non-owner cannot mint. We set it to public, then virtual machine dot prank. So you can see we are faking the contract now. Prank Eliza. Let's say Eliza is trying to mint. Will you be able to mint? Then virtual machine dot expected. So we expected a revert. Expected revert to tell us that it doesn't have ability to mint. So if the contract works fine, it should revert this. It should not give Eliza ability to mint. So token dot mint. So to which address is Eliza trying to mint? Let's say Eliza is trying to mint extra amount to his own address to have more of it. Sorry, Eliza, we are not saying you are doing that. We are just using it to test. So we end the code here. So this one will test if Eliza can actually have the ability. Though we expected it to revert if the code is working the way it's supposed to work. Now, the next thing, let's test for pausing. Let's test the pausing function. Pausing. So we expect the contract to pause in this case. So function test pause blocks test pause block transfer. So when we pause, nobody should be able to transfer the token again. So we want to test that. We set it to public. Then our object notation. So token.pause then virtual machine.expect. So what do we expect? We expect revert. We expect revert. Wow, I've made a mistake. I think I used a expected revert in the last one. Should be expect revert, not expected. When we try Eliza cannot meet, should be expect revert. That's why it's bringing expected now. So let me go back to that code and change to expect revert. So expect revert. So we should take note of this errors so that expect revert, then token. So let's say when we have pause, Eliza is trying to transfer token dot. We now have token dot transfer. Eliza is trying to transfer. Let's say token dot. Let's say Eliza is trying to transfer 100 token out of the 1,000 is having. It can actually transfer 100 out of 1,000 is having. So that's that for testing for pausing. Then we now test on pause as well. Function. So you can see the test is even taking much of our time than the other. Function tests on pause, but it's necessary we test. Function tests on pause allow transfer back. We expect pause to prevent transfers. So on pause, we now allow the transfers back. So we expected that test to pass. On pause transfers, we set it to public visibility. Then the object notation for our function declaration to complete. Then we pass the parameters or we pass the properties that we want to effect in the test. So token dot pause to actually pause the token, to check initial state that the token is paused. So when it discovers the token is paused, we will now unpause it. Token dot unpause. We will now effect token dot unpause to unpause it. Then token dot transfer. We will now enable token dot transfer to actually transfer to Eliza the amount that Eliza is trying to transfer. And it will assert this. Assert equal that the token dot balance of Eliza is updated. The balance of Eliza has been updated with 100 token transfer from his wallet. So we have tested for pausing and unpausing. The last thing to test for is burning. So take note, we are still inside the test file. So as we are pressing enter, make sure you are not going outside the test file. So the last feature is we want to test for burning. Testing for burning. So let's go to the next line. Now function tests. Sorry, it should not be space. Function tests burn reduces. When we burn, it will reduce the total supply. Burn reduces total supply, and we set it to public. Burn reduces total supply, we set it to public. We complete the function declaration with the object notation. Then our integer, unsigned integer 256 character. What's the amount we are trying to burn? Burn amount we are trying to burn. We declare it as a variable. So here we mark testing with 1000. Let's say we want to burn 1000. We define the decimal places on it. So and we set that one to 10. So token dot decimals. We terminate the string. We terminate the code line. We ended it. Then unsigned integer of 256 character to define our initial supply. That's the supply before burning. Initial supply and supply before burning. That's token dot data supply. The supply we have before burning is our total supply. That's token dot total supply. Then when we burn, the amount we burn, token dot burn, that's the amount of token we burn. That's burn amount. Assert equal. So assert equal. I want to define what will be the balance at the end of burning. So token dot total supply. Token dot total supply will now become supply. The total supply remaining now will now be supply before to be supply before minus burnable amount. Sorry, minus burn amount, the amount we burn. So with this, we test for burning. We mock test for burning. So command S, we save it. So this test file for testing our smart contract. So if this work fine, let's test. Let's test. We are successful with our build contract. So let's test our test code. So you can see at the end of the day we have how many line of code? 77. So let's test. In the terminal, forge test. Enter. So we have error. Compiler run free. Expected but got colon. It's expecting comma. That's line 73. Line 73. Okay, good. It's expecting comma, but we put line 73 in the vulnerable amount. Okay, let's change it. It has detected it as error, so we have to change it and run it. Forge test. Unsigned integer 256. Okay, there's error. You can see unsigned integer. I don't put T. So go back to code line 13. I don't put T. You can see how error comes in. First step T, comma S. So let's rerun. So if there's error, that's how it will be picking it one by one. It's garbage in, garbage out. I have the same error in another place, line 24. I didn't put T. Line 24, code line 24. Okay, T, comma S. So don't be annoyed when the code is picking error in your work. I still have it again in line 30. In line 30, you can see it has become a systematic error. Command S. Okay. So to go through it line by line, I'll make sure I still have it in 42. So next time I'll be minding when I'm typing unsigned integer, command T. Okay, let's save. So again in line 68. In line 68, I don't put T. Line 68. 68. Okay. Here. T. Unsigned integer. Then wow, congratulations to us. So our test passed. Our test passed. We ran a total of 9 tests, and all the 9 tests passed. We wrote a total of 9 tests and they all passed. You can see our test for bond reduces total supply passed and spent 25,023 gas. The one to test for initial supply to pass with 15,636 gas usage. The one to test for non-owner can not meet pass 14,520. For test owner can meet, it pass. For test post blocks transfer, that one too passed. For test transfer between wallets, it passed. For test on post allows transfers, that one too passed. So all our tests passed. So okay, it's 7 tests we have in our Bravolag token.ts. So this remaining 2 tests is from our counter smart contract that come with the foundry. So let's the next video. Okay, the next step will now be to deploy the smart contract since all our tests passed. So the next will be to deploy our smart contracts.